Hi everyone, we're still talking about chapter 2 and the Egyptians. On the last video we talked about 6000 BC and the calendar monument that was found in the Nile Valley. About a 12-hour drive north of there in the Nile Valley, there is the Great Pyramid at Giza. And this pyramid was built at about 3000 BC and still reflects the importance of the same constellation that was important to the calendar that was seen from 6000 BC. So at the Great Pyramid of Giza, where pharaohs and queens of pharaohs are buried, there are 4 chambers whose direction is aligned, it seems, directly to 4 important star patterns in the Egyptian night sky at a certain time of the year. So the Egyptians, as you know, were very good at the annual rotation of the earth around the sun, although they believed it was the annual rotation of the sun around the earth. At any rate, they were very skilled in measuring this, and these 4 chambers point to the stars in Osiris's belt, and the Queen's chamber points to the star for the goddess Saptet. These are the Roman names here. On the other side, there are 2 other chambers, and one of the chambers aligns directly with the star Thuban. We'll get into that in a moment. And one of them aligns to a constellation that the Egyptians would worship, Drago. With Thuban, the Egyptians saw that all the other stars revolved around Thuban. The Egyptians were already noting a conflict with what they thought. They thought that everything revolved around the earth, but they saw in Thuban that all the other stars revolved around Thuban. That sounds like a pole star, doesn't it? It does. And if you were able to project your chamber to that star, then you would be moving the pharaoh who was buried there toward universal eternal life. That's what they believed. But Thuban, who's ever heard of Thuban? Let's explore what was going on. The North Star at 3000 BC was not Polaris. The North Star at that time was a star called Thuban. And that is derived from the fact that the Earth tilts on a 23-degree angle, as you know. And now we see that our Earth is tilting at an angle at this direction so that our North Pole seems to have a projected line to the stars that meets right near Polaris. And in fact, as we rotate on the axis, we seem to be rotating about Polaris. But that was not always the case when we were at 3000 BC. The axis seemed to point to Thuban. Well, that would be very, very different. How did that happen? The Earth is actually a wobbling top. And the third action of the Earth that we talked about is precession. Precession is a wobbling motion, like a top would make about its axis. Think about what happens with the top. You spin it, and it spins very efficiently straight up and down for a while, depending on how fast you made the initial turn, the angular momentum of the initial turn. When that angular momentum seems to be reduced by friction, then you start to notice the top starts to wobble as the speed of angular momentum slows down. the force of gravity makes it wobble. In the same way, the Earth is wobbling due to the sun's gravity, but the Earth is not being pulled down. The Earth is being pulled toward the sun along its equator. So this is a way to explain a lot about what is going on with the Earth's axis. And as you know, that axis is responsible for the 24-hour cycle of rotation. You might say, well, why does it have a tilt to it? The tilt is the result of collisions of smaller planets that developed into our planet Earth by forces of gravity. So smaller protoplanets collide and form a bigger planet. This is what our Earth is. Our spherical circle is the result of years of rotation wearing away all of the rough edges. So now we have a very beautiful sphere for the Earth that should spin really effectively, but the sun's gravity as well as centrifugal force of that spin tend to make the equator bulge out, and that bulge sends it off and makes it susceptible to the wobble. When we talk about this wobble, we're talking about a very slow motion. Remember, the Earth has 3 motions: the daily rotation about the axis, the annual revolution around the sun, that's 1 year. This motion of precession takes 26,000 years to do 1 cycle. The reason that it takes so long to do that cycle is because these motions that we're talking about are happening to change direction while the Earth, which has a very large mass, it's kind of like a couch potato, you can't change it too much because it's hard to move it. And you have a rapid rotation like the top that was spinning so well when the angular momentum was conserved. It's hard to change that large mass and that rapid rotation and slow it down and change direction. So a lot of physics going on here. I'm describing it to you in a logical way. That logical way means that if this is 3000 BC down here and Thuban is the projection onto the heavens and the star that seems closest to that projection at this point here, then we are at about this point in the cycle of precession, and we are looking at Polaris. And at about 14,000 AD, we'll be over here and looking at Vega as the North Star. This also has climate implications as well. When we are doing this wobble, and it's a very slow wobble, we are noting that at this point now in our wobble orbit, we are in the northern hemisphere, and January is a month where the sun shines less brightly on our hemisphere and the sun shines more brightly on the southern hemisphere. January is the southern hemisphere winter. With this wobble, it means that 11,000 years from now, the direction of the axis of our Earth will change. And at this point in the revolution, the axis will face in a different direction at the same 23.5-degree tilt. And at that time, the northern hemisphere will get more direct sun's rays. It will effectively become our summer. So we're looking at the same revolution motion, the same rotational motion, but the precessional motion changes the direction of the tilt and changes our climate. so that now this becomes effectively, we call it July, even though it will be January, and it will be a summer January for the Northern Hemisphere. So think about that a bit. That cycle is going to take 26,000 years. To sum this up, the Egyptians used very rudimentary tools to determine their pyramid building and the reference to the stars that were so important to their gods and goddesses. That design of their tool is the foundation for a carpenter's square today. We still use it 5,000 years later. And in the midst of this, in the 1700s, that same design was used for sextants that effectively moved trade in and out of the New World so much faster because the celestial navigation was so much more precise in the 1700s. So your forefathers, your ancestors, did some amazing mathematical calculations and some heavy-duty trigonometry. These were intelligent people that were just caught up in a paradigm that said the Earth was the center of the universe. They made very accurate observations. They measured those observations. They could use predictive powers with that mathematics. They just didn't analyze, and they didn't think critically about why this was happening. So as a result of that, there was a lot of groupthink. And this course is designed to get you to think independently, to take that observation, to take that data, to take that analysis and that prediction and put it into why this is happening and look for evidence for why this is happening. So I'm going to stop it here. We're going to come back and go into how precise the Egyptians could be 3,000 years ago.